Don't worry about it. At the same time, I don't want you to feel like, I can't do it. If I can't finish, who cares? No, do what you can. Do every third problem, whatever. Get enough practice, yes? Don't come to the test with entire sections of homework you didn't look at at all. That's a guaranteed trouble spot, right? Okay. So let me see, 2, 4, 6, 8. Neat. That'll work actually. I want more people to come. That's fine if they do, but that'll work. So let me see from you guys your reaction to this. I can change the plans based on how we feel about this. I wanted to start off with like putting you in groups of 2, having you do some problems from the practice test on the board, and then I was going to have each group kind of do a quick rundown of what you did. Does that make sense? Does that sound okay? Okay. We'll do that. And then the rest of the time will be whatever individual or whatever kind of problems we want to look at. Is that all right? Okay. The way we're going to switch, let me think. All right, I got to get this. Okay. I got to change this up. I was going to have a different way. Alasia, hey. To get groups. All right, so now that Alasia's here, let me keep. That might work. This might get a little tricky. No, you're good. These things happen. I'm gonna have to do this though. Don't you dare. Man, then I'll feel like the ultimate asshole. Now, Classco, I scared a student away. Okay. So there's 2, 4, 6, 8, 9. Okay. So we're just gonna do this. I want you to pick. The future of your life is determined by this pick. That's all. Nothing good. Everything you do from this day forward is going to be changed by this pick. Oh, that's a crazy pick. That's a crazy pick. Oh, that's. I'm scared. I don't know. What does that mean? That one was tricky. I don't know. Oh, that. Oh God, you got that one. All right. You get to pick from this other. You're going to be the third team member on one of these groups. All right. So I hope one of them is going to be yours. All right. So has everybody got like a P, E, R, or L? Yes.
Just 7. All their numbers.
I got a list then, Simple Jeff. What are you trying to say? So I've picked out like 4 kind of groups of problems. So those of you who got the P, who got the P? Who got the P? All right, so you guys are going to work on number 1. You guys with me? Okay, and Melissa, Maria and I can help you. I was looking at Melissa and I was talking about Maria. Who got the R's? R. Kelvin and Kendall. Neat the K's together. You're going to be working on number 8. R for rational dudes. Who got the L's? L's, you guys. And us. And Corinne. You are the log luminati. You're doing, get ready for this, circle this. You're doing 9A and 10B. And then who got my E's? Where are my E's at? All right, Sierra and Aubrey. You guys are the exponential enchanters. You're doing 10A and 9B. Is everybody with me? So, what I want you to do, an array of markers are up here. We've done this before. Groups, pick a marker, grab a spot. You've got several, maybe not that one because you have some interesting deep thoughts, questions over there. You can use this board, that board. We can divvy this board too, or somebody can use that one if you really want to. You with me? All right, so let's do this thing. Come on. First part of class is going to be this, and then it'll be open to whatever. And your group needs to be ready to explain your work to everybody else. Or if nothing specific, I'll talk about that one thing, and then I'll open it up to anything you want to talk about, because obviously we didn't just do every problem on the practice test. There's other ones still there. So let me focus on this idea. This right here, right? And I have to figure out how to do that, because I didn't think ahead enough to like leave this board open. Okay. Maybe I'll just, yeah, why not, Jeff? I'll be like the old days. Maybe I can carve out a bit, I can carve out a bit of space. So, this team here, Exponential Enchanters, you guys kick ass. I want you to know that. This doesn't mean anything. Okay. And you'll know your name. You know your name? Well, now you don't. Okay. So, whenever I'm about to do a transformation, let's say I've got square root of x plus 1 minus 2. Well, let's do logs, because that's what I want to do. So I'm going to do log base 3 of x minus 2 plus 1. Yes? Okay. Very often students can see the transformations. And like Aubrey, I think, said earlier, if you can see the transformations, you can take them out. And then you know what the base function is. The base function is just the untransformed thing, right? So what are my transformations? Right 2? Up 1. So then my base function is this. For a log function, the 3 anchor points I use are kind of analogous to the 3 anchor points I use for an exponential. It's going to be basically plug in 1 over the base, plug in 1, plug in the base. Because those are your easiest things to consider. What do I do to 3 exponentially to make it 1/3? -1. That's the kind of power that makes it flip. What do I do to 3 to make it 1? Raise it to the 0. 1, 3, make it 3. I make it raise it to the first. Okay. Right? Now I've got anchor points that I can do this shit to. And I didn't say this to this other group, so you're fine. But normally what you do to make it easier on the grader is to do your base function in, you can say it, Jeff, dotted form. So let's see, -1, so it'll be 1/3 is -1, 1 is 0, and 3 is 1, and then I do dotted. Yeah. So that's telling me that's not your answer. I need some way to know what your answer is. Yes? And then I just take a point, any point, and I'm going to move it, oh, Jeff, good Lord. I'm going to move it right 2 and up 1. And you can use whatever, I can even use different colors. This is so new to me. Oh my gosh. Oh my gosh. All right, that'll work. Okay. What did I just say? Right 2, up 1. Right 2, up 1. And then right 2, 1, 2, up 1. Okay. Where's my asymptote going to be now? Where was it originally?
0.
At 0 like this, correct? Every element of the graph just moved over 2, correct? So this is going to move over 2. So now it's going to be at x equals 2, which makes sense. There, Jeff, you can do it, buddy. Because now I can see it's doing this thing. Wow! That got really close really fast, but too bad. All right. Yes. And for example, here's the funny thing. At what point is that? That point is 3, 1, correct? It just happened to be the same point as what was on the original graph. 1 moved over into, but if I plug a 3 in, what do I get? What's 3 minus 2? 1. What's log base 3 of 1? Log anything of 1 is 0 plus 1 is 1. So 3 should have a 1 output. Check. So what I just did, whenever you transform, pick a point your end answer goes through and plug it in. It has to work. It's the whole idea of a function going through points. Every point it goes through has to work in that function. That's the relationship. Okay, kick ass. Yes?
What the domain would be for log 3x, log base 3x?
What? Oh, domain for logs that haven't been shifted is always 0 to infinity. Yeah, that's why the original was this, right? 0 to infinity. The whole graph has to exist on that side, right? And now the domain is shifted up 2, correct?
Yeah.
Yeah, so now the domain is 2 to infinity for the shifted 2. Okay. Kick ass. I love it. I agree, Melissa. I'm so tired. You're good. Sorry. Now, we could talk about a problem that's up here. We could talk about a different problem on the practice test. We could talk about quiz problems. What you got, Maria? All right. Student who Maria is channeling right now, can you be more specific, because that's a little too broad? Or can another student who is currently in actual physical form, yes, Kelvin?
Can we go over a practice problem that might look similar to one on the test?
Can that's the same thing that the person who is being channeled by Maria asked. I want something a little more specific. What kind of problem? What kind of problem? I could do that, but what kind of problem?
Let's do the logs.
Okay, what about logs? Are you guys cool if I erase this? Okay.
Not emotionally attached to
Is everybody, well, I want to make sure everybody's got what they need from this. Okay. All right. Sorry, I just remember this one semester, there was a student who always perfectly, I'm like, has everybody got that? Yeah, okay. Wait! I'm like, and she was like, I'm good. Screw you. Okay. So let me get back up here. All right. So the kinds of log questions I gave you. So, okay, there's a whole section on the practice test where that's straight up log calculations, right? Like log base pi of pi and stuff like that. So do you want to look at some of those, or do you want to look at someone like those?
Number 13.
13.
Something.
Oh, something completely different. Okay. And now for something completely different. Oh, let me turn this off. Go away. Okay, thank you. All right. Oh, it's like, why is everything blurry? So this guy, I always struggle with how to word this. Break up into separate logs. Does everybody understand what I mean?
It's a problem.
The opposite of this.
Yeah.
This is put them together, this is break them up. What part of this have I had a rant about that I wish we never invented? Have I had that rant with you guys?
Yeah.
Roots, yes. Roots up. Roots are dumb. Down with roots. And it only makes sense because logs are all about powers, right? So what power is a square root?
Okay. Or how?
Not or. It's just 1/2. So listen, a -2 power would not become 1/2 because it's not raised to a negative number. -2 has never meant. I wish negative. If I owed the bank $2,000, I'm like, no, you actually owe me $1,000 because -2 is 1/2. No, see, it's not going to work. I tried, but I know what you mean. So like, I'll have a student do this, and they'll say that's equal to this, or the other way around, because they think negative means flip. But what's being raised to a negative power? What's being raised to a negative power here? X, so the x would flip, the 2 x's would flip. The 2 is not being raised to a negative power, the 2 is being raised to a first power, because nothing's up there. Do you see that? Okay. So everybody cool with just the one thing I did here? Whenever you have a log problem, and you're trying to simplify it, trying to break it up, any roots you automatically write as powers, because now what property can I use? I have log of shit to the 1/2. Sorry. Just thinking, what's the shit property, Jeff? What property of logs helps me with log of stuff to the 1/2?
Can you bring the 1/2
Yes, the 1/2 power comes out front, yes? And like I said, that's one of the most, the other ones are important, don't get me wrong, but that one is one of the most important ones. That comes out front. Now, what do I have inside the logarithm? What kind of thing is that? What's going on in there? What's the operation inside of the logarithm? Multiplication. And we do have a property, log AB equals log A plus log B. Good. So, you guys with me? You gotta be careful about one thing. What's that 1/2 in front of? Everything. So after you break it up, there better still be a 1/2 in front of everything. So you could just do this, 1/2 in front of everything, John. You just like saying everything. I do. How do I break this up?
1/2 log B x plus 1/2
Yeah, okay, we can do that.
log B 2x.
Is that cool?
Or what you were gonna do, put the whole thing in brackets.
Yeah, I was gonna put a 1/2 in front of everybody. That would be acceptable too.
Okay.
Acceptable? Is that okay? Maybe I'll ask ChatGPT to help me word that better. But break up into separate logs. I'm not sure how to say that otherwise.
So that would be like the final answer.
That is my final form. Yes, that'll be your final. Now, believe it or not, this is going to happen in calculus. There's a calculus method that if you try to do it to this, it's horrific. Do you all understand what just happened? What's the difference between this and this? What's the difference? Nothing. Good. They're both the same damn thing. It's like saying, I said 3 plus 3 and you brought 6. It's like, that's wrong. You guys can know with me. They're the same stupid thing. So if calculus, that weird ass class that you're going to take next, if it says do shit to this, and you're like, you could do it to this instead. And what you're going to find out is the calculus to this is going to be a hell of a lot easier. So one of my mantras I tell my students in calculus is, before you attack a function with calculus, simplify it. Break it down, break it up, do something, simplify it if you can. If there's anything you do to make it simpler, do it, because then the calculus should be simpler. Are you guys all with me? Okay. I know we're not in calculus yet, but just to let you know, the stuff we're doing is going to help you out. Are you guys cool with these now? I mean, here, I think this might be the hardest problem. Definitely in number 11. Does anyone agree with me, or is that the easiest one for somebody? This one has to be the hardest. Yes? I want to show you something. Let me see. I want to show you something about like this. Isn't 16 4 times 4? So how much of this would I need to take to have 1 4? Do you take the whole thing? You would take half of it. Done. Okay. But you can look at it a different way. Square root of 16 is 4, so that's why 1/2 power, right? To make it a square root. Okay. This guy. All right. I'm going to show you a method based on something I showed you yesterday. Has anyone done 11C yet? You have? Okay. Don't say that. Everybody else, if you haven't done 11C yet, I'm going to ask you a really dumb question. What's the answer? Don't tell, if you know it, that must mean you did it. So don't say, if you did it, don't tell me anything. So everybody who did not do it yet, what's the answer? Do you know? I don't know. So what do you call it when you don't know? X, kick ass. You can do this when? You can do this any frickin' time you want to. When is it useful? Not very many times, but now it is. Can you rewrite this problem in exponential form? Do it. 16
X
to the x.
equals 1/8.
Are both of those numbers based on the same number? What do I mean by that? Is there a number that if I raise it to certain powers, I get both of those numbers? Is there one number that I can make both of those from? Yes, 2. What do I raise 2 to get 16? 2 to the what power is 16? How many 2's do you multiply to get 16? 4, yes? What do I raise 2 to get 8? 3. So what do I raise it to get 1/8? Negative 3. Somebody with me? So 16 is 2 to the 4th, and there's already an x up there. Is that cool? 1/8 is 2 to the negative 3. What must be true about these then? We made the bases the same, so the way to make the equation true is to make the exponents the same. And then you got a dinky little 4x equal negative 3 to solve. You guys see that? Now let me do this. Is everybody cool with that? So you get negative 3/4. Let me show you this. Watch. What if I didn't have the, let me just take the 1 over out of the equation. You with me? This here? 16 is 2 times 2 times 2 times 2, right? How many of those do I take to make 8? Out of how many total? 3/4. So what if it was 1/8? I would make it negative 3/4. It's the same answer we just got, right? So I mean, I'm not saying you should try to do your problems this way. I am saying if you get more comfortable with logs, you can start to realize that's what they really are. If the things are based on the same number, they're both based on 2. Oh, break 16 into 2. How many do you need for the other? 3 out of 4. Okay. Oh, I need to flip. Oh, negative. I don't know if you guys are with me or not. I don't know if you can do that now. Don't try to do it now. We're trying to get used to logarithms. But I'm just showing you there's a nice quick way to do logs. Okay. Is that all right? What's next? Another kind of log problem, or you want to do a different kind of problem? As I slowly pass away. It was really good. I didn't know you guys.
Can you do 12? You're just simplifying this.
Oh, no, that's the one I can't do. No, yeah. Oh!
It's just the opposite of that one, but.
Yeah, so let me ask you this. Do you have a property for log minus log? Like log B stuff minus log B stuff? Okay. Do you have a property for log base stuff minus 2 log stuff? Do we have a property for that? No. I have log plus log, I have log minus, I don't have log minus 2 log. So do you see how the 2 is in my way? If only a damn 2 wasn't there, I've got a property for log stuff minus log stuff, right? How do you get the 2 out the way? Yes. Now it's out the way. What's log base 5 of this stuff minus log base 5 of this stuff?
Log base 5 is that stuff over this stuff. Scientifically.
Technically, you're right. Now, real quick. Do you guys see how you're not done? You've finished rewriting the log, but have you simplified it? No. What can you do on the inside?
Can we factor?
Yes, factor. You factor the top and see if anything cancels. How do you simplify a fraction? You see if it reduces. Don't have a fraction inside, so I've got to see if it reduces. How do you see if it reduces? Factor the top, because the bottom's already factored, right? Bottom's like, come on, man. I ain't got all day. So what can you do on the top there? Take a 5 out, right? And then that factors really nice. So just to make sure I'm on the right track. The 5 can only go so far when I take it out. It can go right there. How do you factor this? Yeah, so these cancel. You guys see that? Then you get log base 5 of 5, which is? What's log base 5 of 5? 1. All that shit is 1. Some people get upset about that. And I'm like, that's the coolest thing in the world. You just go, all that shit made a 1. That's beautiful. Look at that. Look at math go.
Well,
Yeah.
I think they're more upset about how you got all that shit from 1.
Oh, yeah. Now that's a whole thing. Real quick. I don't know if you know about this yet, Maria, if you've gone far enough. You get to a point in mathematics where you start to have there was a list somewhere in my house. There's a list that I had when I was like 19. And it has all these different ways to write 1. Right? 1 equals that. 1 equals like there's some trig identities that equal 1. There's weird ass calculus shit that equals 1. Because what can you multiply by and not change the result? 1. So if you know all these different forms that one can take, you can multiply by any of those anytime you want. Are they always useful? No. Are they sometimes useful as shit? Yeah, I'm sorry. That was a little much. I don't know if you guys really follow what I'm saying, but yes.
For 12, I did it kind of differently.
Yes.
And I still got the same answer.
Yes.
So I'm not sure.
What'd you do?
So I factored.
Oh, you factored first?
Yeah.
Okay.
So I factored first, and then I used like the product one, and I split log 5, 5, and then log 5 x minus 2. So
Oh, you split them up, but my instructions said rewrite as a single log. Now, you're gonna get this.
Well, oh, fair enough.
You're gonna get the same answer. You with me?
Yeah.
Because
so
the math don't care when certain things happen; they just have to happen sometime. You're gonna get the same answer, but
Yeah, I did get log 5, 5 at one point.
I got
and
you.
just simplified.
so you could argue, hey, that's a single log, dude, and I would have to say, yeah, you're right. So yeah, you're fine. What I meant was to put them together from the beginning, and you're like, nah, Jeff, I can get a single log a different way, so I'd have to give you the points for that.
You circled 1, so I guess
I did. Oh, that's a good point. Rewrite as a single log and simplify. Yeah.
and
Yeah.
okay.
Simplify.
Math is like the Grim Reaper.
I mean, that's one way.
No, but I mean, you were saying like it doesn't matter when it happens; it just has to happen. It's like the balance of the universe. Like death doesn't care when you die, as long as you do something.
Oh, I see. That's interesting. Right. I guess I'd rather die later than now. Math, and you're gonna die sometime, man. Your ingest problem is gonna kill you at some point.
Have you seen that Disney movie about the piano player who dies early and what's it called?
Piano player dies
Soul.
early. Oh,
Yeah.
that is one I missed.
You need to watch.
I love all those.
because you would love the abacus
Probably.
guy.
Probably. I can't believe I missed that problem. That problem. I'm in freaking
There's
teacher.
a
That I missed that
character-
movie.
There's a character in it, and
I
like
tell you. The movie I love and hate the most is Up. That movie can go to hell. How dare you make me feel so much? Look at them together. I'm sorry if you've never seen it. If you've never seen Up, then see freaking Up.
Yeah.
Just, go into it needing a good cry. Then you'll be happy.
you have to have at least one pint of Ben Jerry's to watch that movie. At least.
Yes. Okay. Where to next, everybody? Any problem, I can make other problems like it, by the way. Of course. Yes.
So on the homework, 6.524.
Oh, okay. I don't want to pull it up because I'm lazy. Oh, okay. Let me write that down. Do I have paper? That would be so useful, Jeff.
I do have something to do. Okay.
I bring no paper.
I have paper.
I got some. Thank you, though. I appreciate everybody. It takes a village. So, what was it in? Log base.
You say 6.5?
Oh, 4 log base 7 of C plus log base 7 of A over 3. Is this the one where they tell you what they tell you? Anything?
So for the following exercise, can dance.
Where's it? Sorry. Oh, okay. All right, I got you. All right, guys. So here's the problem. Now, what's funny is there is a issue with how they've written it that is related to when students first learn lines, right? Legal. The like y equals 1/2 x plus 2. You can write that as y equals x over 2 plus 2. I don't know if you guys followed what I just said. If I have y equals x over 7 minus 4. Can anyone tell me what the slope is?
1/7?
Can you see why students might have trouble with that?
Yep.
It's much better if I write it like this. Now, think about what I just said and look at this problem. Think about what I just said and look at this problem. Yes? Why is this easy? What are you going to do with that 4? Yeah, so if only I had a freaking actual number sitting out here. So how do I rewrite this?
Log, or 1/3.
Yes, 1/3. Log 7a plus 1/3. Yeah, log 7b So now what can I do with those 1/3?
Put 'em up there.
I'll tell you what to do with it. Let's be quiet.
Put 'em up.
I knew it was gonna happen someday. One of my students held me up. And then the final thing I could do. What can I do with all this business? When I add logs, what do I do with the stuff inside? Log A plus log B is multiply. So then this would be C4. Apply a bunch of that to A 1/3 and B 1/3, and then step back.
Yeah. You know one.
Yes. Huh?
You said 1/3.
Where did I get it?
Yes.
Oh. Are you talking about like right here?
Yes.
Okay, are you cool with this?
Yes.
So then you must be cool with this. It's exactly the same idea. Yeah. So they just wrote it weird. I'd rather have it as a coefficient because any coefficient of a log I can put up in the power. The way they wrote it, it doesn't look like a coefficient. Cool. Yes.
So, can I write it log base 7, C to the 4th power plus A to the 1/3 power plus B to the 1/3?
No.
Oh,
The
okay.
sum of the logs is the log of the product.
Okay.
That's how they have to work. Because when do I add powers? When I was multiplying the stuff. Yeah. I add powers when I was multiplying. Yes.
What is the change of base formula?
Oh! Oh my god, Jeff. Okay. What was that stuff? I don't know. Alright, I forgot. Oh man. It's one of my favorite things in the world. The funny thing with the change of base formula is it's not as useful anymore because now calculators, if you search through your math button, there's actually a log of any base. But before we had those, if I ask you to do this in your calculator, it's really easy to do it. Do you all agree? Could everybody do that in your calculator if you have your calculator? I would guess it's about 2.479.
2.397.
What is it?
2.397, and then it keeps
That's not too bad. That's pretty close. So is everybody getting 2.397? Blah, 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 blah. Okay. So I'm trying to remember, if I don't say how many things to round to, just round to a couple places when in doubt. Huh?
Because a couple is
That is so true. So a couple places. Huh? A few is 3. Yes. I put 3 just because that's what I was told. I'll do what I'm told. Now, let me ask you this. Can you do this easily in your calculator?
No.
You don't agree?
Yes, you can.
Try it.
I mean, just using the buttons available on the face of your calculator. Or do you have to go into a sub menu?
I think it's a 7.
Kel, listen to me. I'm with you, man. Here's the thing about, where was the change of base formula on us? Do you remember where it was? Where'd you see it?
Actually, the question, because it's.
That's too early. That should be in the next section. This is
So
so.
it was the one below it. So, which is it, 24?
Yeah.
And that question was 27 for the following exercises.
Oh, I see. That's weird.
What?
What section is this again? Is this 6.5?
6.5, yes.
6.5.
What
Okay.
I say.
Oh shit. What have I done? Okay, I'm with you. Okay.
We're back.
Yeah. Okay. Okay. We're back. So real quick, guys. This is a little early, but I didn't realize they did this. They should have done it in the next section. Do you see what I did?
Mm-hmm.
Same thing I did earlier, right? I don't know what the shit it is. I'm gonna call it X. Can you guys rewrite this?
11 power x equals 7.
Kick ass. Now, what's a better? Now, real quick. Now I've made a problem for myself. the value I was interested in, I now shoved it up here in the exponent, correct? But now I could use whatever log I want to. I'm going to use a log that's on the face of my calculator, right? So, and since I'm a math person and I'm lazy as shit, I'm going to use the log that has the least number of letters, right? So now I can bring this down. And then how do I solve for x? Divide by ln. Now, I want you to compare. Is that cool, guys? What is x? X is this. X is also this. So then this is this.
Ah,
What was the base of the original problem? What was the base?
11.
And now it's on the bottom. The base went on the bottom.
So noted.
So if I want, this is why it's called the change of base. What was the change? What was the base originally? 11. What is the base of the log I'm using now? E. And that is on the face of my calculator. So now I can plug this in, and I'll get the same answer as this. Let's all try this. Can you guys do? You got to be really careful with calculators, because you have to do natural log of 7 divided by natural log of 11. I can't remember if it opens a parenthesis. All right, Jeff. Let's see. Am I still lucky, punk? Am I still lucky? No.
The battery's exploding.
Huh?
The battery's exploding.
Don't do that to me. It's a very calm way. Hey, your battery's.
Well, it's about to.
Oh, yeah, I agree. This thing, I don't know what's going to happen to it.
Boom.
Like
If you hear that in a minute, you're like, oh, it's good to know Jeff for a while.
Yeah.
So natural log of, yeah, it does open a stupid parenthesis. You have to close it. If you don't close it, everything else you type will be inside that first natural log. Do you understand? So I don't want 7 inside of him, divided by natural log of 11. Now, real quick. Let me see if you guys are really cool with this. What the shit is that? What is it? What is it? What is it? What's special about this number? From what we've done, what is that number supposed to do? You can do it. You can do it. I know you can. What is x equal? What is it equal to from the beginning? This.
Oh.
What does that represent? It's a power, correct? It's the power that what needs to become what?
Or 11 needs to be
It's the
7.
power that 11 needs to become 7, yes?
Mhm.
That is how you always interpret the output to a log. So if I raise 11 to, and I've shown you this button before, right? The answer button.
Mhm.
If I raise 11 to that number, the last number on my screen, I do get freaking, well, do it. Jeff. Oh, you almost hit the right number. I do get 7. Do you see that? That's kind of nifty. On one level, you're like, well, duh, Jeff, of course you do. But on another level, it's cool. I raise 11, do it, I get 7. That's what it was supposed to do. Maybe? Next kid. I was like, good job, you, sir. Okay. Is that okay for that? Okay. So the change of base formula is officially this. Log base b, oh screw it, Jeff. Log base b of a is equal to natural log of a over natural log of b. Jeff, the base goes on the bottom. Base goes on the bottom, yes? So how would I do log base pi of the square root of e? Square root of e? Yeah, you just shove that in a little calculator, yes? Now this you can simplify, but who cares? I just want to know the change of base, yeah.
I was just gonna say, can't you just get rid of the ln and the square root of,
Totally. Now that you got rid of his ln, the top just becomes,
it just becomes the square root?
no.
Oh,
E to the 1/2, the 1/2 comes out, ln of e is 1. So let me show you the steps. Y'all agree that this is ln of e to the 1/2? Yes? And then the 1/2 comes down. And what's ln of e? 1. So then it's just 1/2 divided by ln of pi, whatever that is. I'm gonna say your answer is roughly 0.472. But nobody's doing it, so I'll never know. Did I do that right? We'll find out, Jeff. I think it's 0.472. I'm gonna stick with it. I'm like, all right, Jeff, whatever you say.
What does E equal again?
Do it again?
E equals 1.
Shit and a half. I keep putting more extra shit. What did I say? That's terrible, Jeff. All right.
I don't think E equals all of them, unless I missed what you were talking about.
I'm sorry, say it again. I missed what you were
So
saying.
what does E equal?
E is like
2.71828, blah, 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 blah. It's a number, not equivalent, how do I say this? It's analogous to pi.
Okay.
Pi is special because it came out of circles, no matter how big or how small. E is special because, did I show you guys where E came from? Yes, it was the area underneath 1/x, for example. And then the other place it comes from is letting x get really big and 1 plus 1/x to the x. I don't know if I showed you guys that one. That one's important. Huh? Natural log. It just means log base e,
Oh,
but we gave it a special symbol because it's related to a special base.
gotcha, because that's what you're saying before it only writes long base E.
Yes, and I'm never gonna write it again for you guys. I've already done it twice, and it physically hurts to do it. That's just this stuff. Sometime in history they said, no, it's called so now all math teachers use this most because it has one less letter. Okay, there's nothing special about it beyond that. What is that, Jeff? Ooh, look, that's calculus. Okay, so, I don't know. Do we have any paper, Jeff? No, I've run out of paper. All right. Anything else we want to discuss? So you got your multiplicities, intercepts, factoring, synthetic division, long division, rational. I mean, this is a decent test. Factoring? Okay. Yes.
Sorry.
Okay, next.
You said that this test is only going up through 6.5.
Yes. And that's properties of logs. So 6667 will be on the next test.
Okay, does that mean that work is due?
Do the next, like test 3.
Okay.
That homework will be due. So you don't have to do anything past 6.5 unless you really feel the itch to do it.
Test 3 is after Thanksgiving.
I don't know. That's why I made that sheet, because I can't keep it up here. It's on that sheet.
Can we do,
November 17th.
Before Thanksgiving.
Yeah, November 17th.
do another one of those million part problems with the finding the asymptotes and the.
Oh, sure. All right.
That stuff.
And now I gotta find. Corinne, you said you had a paper, right? No, you have line paper. I can't.
My line paper? Is that OCD thing or
I
what?
can't. It's sort of, I guess, maybe.
I'm just curious.
I'm sorry. I appreciate you were ready to help me. I just forgot to bring paper. Thank you. Corinne gets 1 extra point. Fatima gets 2. Maybe not. Okay. So we're gonna have an exciting time. We're gonna make up a problem, and we're gonna see what the hell we've done to ourselves. So make sure I remember, Aubrey, because my memory is that good. Rational function, yes. Rational function. Ratio,
Yes.
like define asymptotes. Okay. All right, let's do one. For some reason, I haven't done one like this yet, which is interesting. Yes, Jeff, very interesting. Okay. 3x minus 12 over x squared. You could do it, Jeff. Let me think, hold on. Yeah, okay. So then, you've done that one already. Minus 8x plus 15. Is that right, Jeff? Yeah, that'll work. Oh, it's a little weird, but that's fine. Alright. It's gonna be weird. Alright, so on the test, I'm gonna break this up in parts. So normally the first thing I ask, what's the first thing you do?
Factor.
Yeah. So what do you get on top? What'd you say?
X minus 3, X minus 5.
Yes. 3 and 5 make 8, and they make 15, blah, 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 blah. Okay. Anything cancel? No. So you don't have any holes, you got some walls though. So where I normally start, if I remember correctly, is intercepts. So if I just say intercepts, make sure you get the X and the Y. Sometimes people forget about the poor little Y dude. Do we have, how many X intercepts do I have? Be really, 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 really careful. You only have one X-intercept. These two are gonna make what? Vertical asymptotes, good. So I'll have people just see 4, 3, 5, their brain just sees it, and they think they're all intercepts, and then things get weird. Okay. So I got one X-intercept. My Y-intercept is easier to see here, yes? Because Y-intercept makes X 0, so what's my Y-intercept?
Well, it's negative 12 or 15.
Negative 12 or 15, which reduces to be, yeah, 4 fifths, negative 4 fifths. Negative 0.8. So we can do it by hand, yeah. Alright, so I'm going to ask you intercepts. I'm going to ask you asymptotes. Vertical asymptotes, horizontal asymptotes, the va and the ha. Vahala. So what is, I don't know. Do I? I'll see you with Vahala. So
3 and 5
what's the Va?
actually equals 3.
Kelvin, I love you, man. Kelvin's like, just answer his question, sure will shut up. Alright, X is 3, X is 5. Right? That's the hard walls. That's the walls you cannot exist here. And what's the suggestion for as you go along? What situation are we in? How do you tell? I haven't given us this one for some reason.
Well, the bottom is bigger than the
Bottom degree is bigger than the top. Bottom is growing faster, so the whole thing is getting
It's closer to 0.
smaller going to 0. You guys with me? If the bottom degree is bigger, I'm dividing by more, so if I let that happen forever, I'm going to go to 0. Am I ever going to get to 0? Nope. I'm going to get as close to 0 as you want. Y equals 0. What now, Jeff? I don't know. Then I would give you some points, but let's do this. Let's see if we can tease out what points we need to do. Yes? So I've got it looks like my x-axis, my x-axis can go by 1s, especially if we go 1 more. Not much is happening on the negative side. I'm not going to make my y scale yet, because I don't have enough information yet. What can I put down here then safely? Yeah, I got my intercept, 4, 0. Yep. And the walls go dashing down. Alright. Tumble in, tumble in. No, that song's a man. So, this is exceptionally weird. Do you agree? Does everybody understand when I say that? Because how many regions did we just break this up into? 3. We have a y-intercept. So we do have information here. We just haven't plotted it because I don't know what my y scale is going to be. What's the multiplicity of where this came from? Now, real quick, don't say anything. Can you imagine what it could look like in here then? Multiplicity is 1, yes? Y'all, Mr. Kelvin's back to dancing the answer. Oh, so it's Kindle. All right.
Oh.
So it could either be, yeah. So it could either be like this, or it could be like this. Yes. Y'all with me? So I have be very happy I didn't make this for the actual test, because what can I plug in to figure out which one of those it is? How many points do I have to plug in to figure out which one of those it is? Just one. Somebody have a suggestion?
4.5.
4.5, that works. So if I plug in 4.5, is anybody excited about doing that?
No,
Which is not
we
really.
didn't like what's up.
So,
No one's excited about that.
If I plug in 4.5, this would be 3 times 0.5, is that cool? Over 1.5 times negative 0.5. This is kind of nice, actually. These cancel. What's 3 divided by 1.5? 2. And it's negative, yes? Yes.
Well, sorry, that's what I was asking. They cancel even though the one's negative?
One's
Like, how
negative,
does
yeah.
that work?
So, what do you mean? Sorry.
How do they cancel if one was negative?
No. There's a negative sign.
Yes.
So if 3 divided by 1.5 is 2, what's 3 divided by negative 1.5? Negative 2, yeah. So when we plug that in, we get a negative 2, so I know it's going to look like this. We still don't know what our scale is for the y-axis yet, do we?
Nope.
I do have a horizontal asymptote here. I could put that down safely. Is everybody cool with the fact that we went through it there?
Yeah.
Because why? Why is it okay we went through it there?
This is-
X is small. Also, I can go through an infinite number of times, thank you very much.
Okay.
But for the ones we're doing, it's fine when X is relatively small. Is everybody understanding what I'm going through here? So I made a relatively ugly problem because I just made it out of nowhere. So there are no other x-intercepts, correct? So what could I look like back here? And actually, we have information. We know what our y-intercept is. What's our y-intercept? Where did I put it? Oh, there it is. Negative 4 fifths. So I know I'm down here, so I know this is going to look like this, yes? All right, now, I'm still out. I don't have my y-axis scale yet, do I? What's going to happen over here?
No clue.
How do I determine? What could it be? Could be like this or like that. Can everybody see the two things it could be? It could only be this, because it's got to slam against that wall and slam against that wall, yes? Or it could be this. That's the only two things. So if I just plug one number in, I can see which one it is. So obviously a good number to plug in would be 12. Oh, 6. So if I plug in 6, I'll get 3 times 2, yes? Over 3 times 1. Okay, that kicks ass. So now I can make my y scale. I'm going to make it a little bit 1, 2, little Fisher-Price scale. -1, -2. Okay. So 6 has an output of 2. My y-intercept is negative 0.8. So let me see if you guys are cool with this. That's all we need. Now I know I go like this. Try to make it really clear to me that you know what it's supposed to be doing. Are you with me? Okay, yes?
4.5 was negative 2? Is that okay?
Oh, yeah. 4.5 was negative 2. Yes. So 4.5 was negative 2. So now I can go like this. Because it can't be like this because I'm supposed to go through this, yes? Now, if you didn't like multiplicity, you didn't do it, you would have to plug in like 3.5 and get something up here. You guys with me? But if you know multiplicity, you only need one of them because you know you go through. How are we all feeling about this so far? Okay. And over here, I got everything I need. I've got to slam against this wall, and I've got to slam against that wall. Shaboom. So in calculus, you'll be doing the same thing. You'll just have more information. For example, do you guys see how this is curving like this? Couldn't I, and do you all agree this is increasing? If I go that way, I should say. Like, just go with me. Couldn't I go like this instead? Do you see how that's the kind of the opposite curvature? Do you guys see that? So in calculus, you can do stuff to the function and make it tell you, when are you curving like this and when are you curving like that? You guys at all with me? In calculus, you will learn a method that you can take the function, do some calculus shit to it, and it will tell you, is it curving out like that, or is it bowing up like that?
If it were doing this, wouldn't it have to do some really freaky crap at the asymptote?
Hell yeah.
Okay.
Well, we've seen functions. We saw one earlier today. That's really hard to see over there. I'm glad you guys are all over here. It could totally do this, and then kind of curve back. Yes? And then you'd even calculus, you'd even see that point right here. There's a point that's really interesting. That where it goes from curving up to curving down. Do you see that? Anyway, that's all I'll say. So when you get to it, you'll like, oh yeah, that's what that weird ass math dude last semester was talking about. Is that okay? Okay. Okay. Anything else you'd like to discuss? Got time. I'd like to know all of the answers to the question. They are a collection of letters and numbers. Yes?
You have to use the quadratic one, don't you guys?
Possible. Right, if I ask you to find all the zeros and you get it down to like a square thing that doesn't factor, then you have to use quadratic.
Let me just put it to like a half.
So you
Let me just put the power to a half.
no. Yes.
Number 21 in 5.6.
Oh, okay. What's it say?
Yeah, I got it.
Is it a long thing?
No,
Should I look it up? Oh.
it wants the x and y intercepts of f of x equals x divided by x squared minus x.
Oh yeah, this is a good one. I love this one. You would, Jeff. All right. How do you find the y-intercept?
Make x 0.
Make x 0. Oh, that's Kelvin. That was so creepy. You see him? God damn. I was. Jesus Christ. Sorry. I saw him first. I'm like, oh, and I saw Kelvin's. It must be him. So if you plug a 0 in, what happens?
It freaks out.
Oh, freak out. That would be 0. That would be infinity. That is. Oh shit. That is what we call indeterminate. All you have to know is there a y-intercept? No. There is no y-intercept. Because when you try to make x 0, it freaks out. Oh, freak out. Now, real quick, if you were to simplify this, what do you get? You see that? You can take an x out on the bottom. What happens?
X is canceled.
X is canceled. So this is equivalent to this everywhere except x equals 0. So if you plug a 0 into this, what do you get?
Negative
1.
1.
Now, let me see if you guys can piece all this together. Before I canceled this, there would have been a vertical asymptote where, if that was a 1, where would the vertical asymptotes be?
X equals 1.
1 and 0, yes? That canceled. So there's only a vertical asymptote at 1, yes? So what's happening at 0 then? There's a hole. Where is the hole exactly? 0, negative 1. There's going to be a hole there.
Why?
Does it make sense what I said a second ago? This is always true except, everywhere except x equals 0. Because what is the one time you cannot do this division is if it's 0 over 0, yes? So this is, this function equals this everywhere except at 0. If I plug a 0 into this, I can see where the function wants to be, but I can't let it be there. There's going to be a hole there. I want that to make sense. So I can see, if I plug a 0, I'm like, oh, you poor little dude, you wanted to be at negative 1, but you can't be because I'm not allowed to let x be 0. So I'm pretty sure I talked about it, guys. We talked about a problem where we figured out how to figure out where the hole goes. I'm like, if it cancels, there's not a vertical asymptote, there's a hole. And then the next natural question should have been, where the shit do you put the hole, Jeff? Just wherever you want to? No, it's got to be somewhere specific. It's where it would want to go. Yes?
It's a little unrelated, but what would a hole represent? Like, what scenario would you have like a function that goes everywhere except for like one spot?
That it just means there is no output at that input. Yeah. Coming up with a physical example is a little weird.
Okay, so it's maybe not relevant.
But it'd be like,
Wait, so someone made this shit up for fun?
no, okay, I'm sorry. There are physical examples, but they're a little trippy. Because you can imagine this is not going to happen too often in the real world, correct? but there are definitely places. In fact, there are areas of mathematics where the entire study, and it's not just math, it's physics, where the entire study is, oh yeah, we got 0 over 0, right? You guys kind of with me? So trust, there's a ton of them. I'm trying to think of something where you don't have to understand freaking physics to get the idea. I don't know if I can come up with them on the spot. It's kind of like, how about this? How about if you keep putting more and more weight in an elevator, right? Or like a really simple elevator. What do you call those things? Dumb waiters? And you got you're trying to figure out. So this is a really dumb way to see how much weight. So you're just going to keep doing it until it breaks. So the instant you put it down and it breaks, that would be an open circle because it can't have that input. The whole thing goes to shit. Does that make sense? That's the best quick physical example I can come up with.
Why wouldn't that be an asymptote though? Because you couldn't put more weight than that either because it's already broken.
It would be the end, like the domain would stop. There'd be an open circle. So if I'm recording how much weight I'm putting in, the minute I put that weight and it breaks, there would be an open circle there because it's not a perfect example. Don't try to break it down.
No, but it's no longer approaching it. It's just
Yeah, the function is no longer existing because the thing it was modeling is gone.
Okay, sure.
12 pound, okay. We'll build it again.
That's like the old Calvin and Hobbes joke about how do they determine how much weight can go over a bridge. They build it once, they take trucks across. When the truck gets too heavy and the bridge collapses, they build it again, and now they know. Maybe that's not how they do it.
Well, the hard knocks.
Yes. So that's the y-intercept. How do I get the x-intercept? Well, if this function equals this, everywhere except x equals 0, I can now, let me see if you guys are cool with this. I want to let f of x be 0, correct? How do I find the, actually, let me do this. How do I find the x-intercept?
You make y 0.
Make the output 0, yes? Now I'm going to try to solve this. Are you with me? So I'm going to do the same thing we did just a second ago, because this is legal to do. Now, real quick, can you see that every x you put in, except for the one that you're not allowed to use, isn't the output of fraction? Put a 7, you get 1/6, right? So how do you make a fraction 0?
The top has to be 0.
So this equation is saying the answer is the number that makes this fraction 0, but the top is always. So is there an x-intercept? Do you guys see that? In order for this to equal 0, the top has to be 0, but no matter what I make x, what is the top? So is there a value of x that makes the output 0? Is there an x-intercept? No. So this has no y-intercept, no x-intercept. Did anyone try to graph this? So as a student, if I'm like, what the flip does this thing look like? Right? Try to graph that thing. Okay, we're done. That one's trippy, I agree. I remember assigning this, I just was like, let me see what they do. Do you want me to give this to you on a test? I could be like my old teachers, and I remember he gave this test back, we all complained, we never talked about number one. And the guy's like, oh yeah, I just wanted to, I remember he always did this with, I just wanted to see what you guys would do with that. And we were like, shit, are you talking about?
So I graphed it and it gave me a y-intercept.
Wow. Okay.
Okay.
I know.
No, it didn't. You ready? You ready? Are you ready? You're not saying anything, so I don't know if you'll.
Sure.
Okay, thank you. It was this here, right?
What?
Sorry.
Yes.
Okay. You ready? It looks like it goes through, doesn't it? How big would a hole be that the graph is graphing?
Itty bitty.
1 pixel big.
Okay.
Right? I don't care how many glasses you put on me, I ain't gonna see that. Now watch. Do you guys know, have I shown you if you do second trace value, you can say what is it at 5 and it tells you the output. Is that cool? So if I do second trace value and I put a 0 in, you with me? It's gonna say whole. See it? What's the output? It's kind of cool to see. That's what you would expect if there was a hole there, is when I put an input, it doesn't give me an output because there's a hole there, yes? If I just look at the graph though, Aubrey, you're right. It looks like it goes, what the shit? Because the hole is 1 pixel big. I wish they would have programmed this to make it like overstated. But no, they didn't, so what do you want? Is that okay? Yeah. So be really careful when you're checking weird things out like this. You have to go one step further. And this is, I love this. I love that that's just empty. It's like, yeah. What's that?
If you zoom in on the hole.
Mine doesn't.
Oh,
But I
really?
have to see eyes.
Yeah, if you zoom in like a lot of times.
Like a lot of times.
Yeah. Zoom
Oh
in.
yeah, because it's trying to resolve
You gotta do it like
something that's
at least-
basically.
at least 10 times.
Okay. I'm with you. I appreciate that you did that, Kendall.
Yeah. No problem.
I like how
Because
when you
you
said
are
got these crazy eyes.
You start to get to the limitations of the resolution of the calculator. So it's doing the best it can with things that are getting really close to infinity in some way. Yeah. Poor little thing.
It tries.
It tries. All right. Anything else, guys? I think Maria said something about factoring, but are you guys cool with? There was that one problem I put on there that was like a cubes.
Yeah.
You guys cool with cubes?
So
No? Okay. So let's do x cubed plus 8. So if it's two terms, it could only be two things, unless you forgot a GCF. It could only be squares or cubes. This one is very obviously. Now be careful. If I had an x next to the 8, it wouldn't be cubes. If I had x cubed plus 9, it wouldn't be cubes. You have to be able to cut everything in thirds. And I can cut everything in thirds. So what do I get when I cut them in thirds? What's this?
That's the
X, X,
third.
X.
What's this? Okay. And what do you slap down?
So oh,
Not soap yet. What do you put down here?
X plus 2.
Little
Oh, that's it.
dude. You know, I've been teaching since 1998. And so few times has somebody like humored me and said little dude, big dude. But it's okay. I'm gonna be okay. Does nobody like little dude, big dude? It's just me. It's fine. I'm okay. So, what goes in the little tiny dude?
Soap is less syllables.
But soap is what you do after you've gotten this put down, right? So this gives you the structure, and then you fill it with soap. So what goes in the little tiny dude?
X plus 2.
Yeah, one of each, because he's a little tiny dude. What sign?
Same.
Soap, same sign. Same soapy sign. And then what goes here?
X squared.
X squared. And then what goes here?
4.
Yes. And then what goes in the middle?
Negative 2x.
Negative 2x. Kick ass. If you have time, how do you check it? Multiply that shit, yes. Although, of course, we know it would actually be because now there's a middle term. FOIL means first, outer, inner, last. Anyway, I'll stop. I'm sorry. I won't go on my FOIL rant again. Is that okay? Little dude, big dude. What did I tell you about the big dude? If you set this equal to 0, what's the only real answer?
Complex.
What's the only real answer?
Yeah, wait. That one. X plus 2. X minus 2.
There it is. X equals negative 2.
You got there.
I knew, I could sense you were going, you're gonna get there. This will always give you imaginary answers. I'm gonna push my luck just for a second because this is way too cool, and if you never take it again, you might never see this shit. But do you remember let me see if you guys are with me. Remember the real and the imaginary?
Yeah.
You remember that? And we like what? So when I do a cube root, I'm gonna cut this in thirds. This is 360 degrees, right? You with me? So for this problem, let me make the, it doesn't matter, Jeff. I'm gonna get one real answer, and then 120 degrees later, I'm gonna get another answer, and then 120 degrees later, I'm gonna get another answer. And then it comes back to the beginning. Is that 120? It don't matter, Jeff.
Yeah.
You'll get it. Okay. 240 would be about right here, yeah. So these are what kind of answers? Are they purely real? No, they're a little real, a little imaginary. They're a little real, a little imaginary. You guys see that? That's such a cool idea, and you guys don't get to see it very often. Because even when we get there, we sometimes don't have time to get into this, but that's how a third power works. It breaks it up into 3 parts, and you can see I'm going to get one real, imaginary, imaginary. That's kind of cool. So that's why the big dude only gives you complex solutions. Okay.
Isn't that sine?
No, you're thinking about unit circle on compass.
Yeah.
It's not that. Because this is real and imaginary. This is not angle necessarily. It actually is, but we didn't make that connection yet. But it's not unit circle.
Like root x over 2?
Huh? Root 2 over 2 is a trick thing. Don't bring that in yet. Okay. I've run out of even my donated paper. Alright. Anything else that I can go way too far about? So I haven't really talked too much about like test taking tips. I think I said maybe a little bit, but when you get the test, find a problem that you know for sure. Do it. That does 2 things. It lifts your confidence and make sure you get that one done. Because a lot of students, they'll get stuck and then they'll go to turn and like, oh, I ran out of time. And like, I could have done number 8. Damn. You know. So I'm like, find it, do it. Confidence goes up, you get that problem done in your belt. You with me? And then of course, if anything's not clear, come up and ask me. If your calculator starts smoking or freaking out, come up and show me.
Yeah.
Don't just put it over there and go, that's my life. You gotta smell something? Maybe. I'm sorry. I'm too goofy for anybody's own good. Oh, I'm sorry. I totally did. I'll do it right now.
Oh boy.
Alright. Give me a minute. Alright, here it is. Huh?
You making a mistake on this or no?
Define that. You guys seem great. Very sorry, my handwriting. I didn't get enough. Want one? I understand. That's gonna be true about a lot of things. If you still have your little slips of paper, you can put them up on your fridge. That was a part of the PT. So take a look at the key. Let me know if you have any questions. Let me know if you spot any mistakes. Did I actually finish all of them? I did. Ah, look at me go. That doesn't mean I did them all right, so we'll see. Pretty sure I did. I went a little quick at number. Oh wait, I didn't finish number 5, did I? No, I did. I sort of did. Real quick, guys. I did this. I told you -2 went in. But do you see how I don't? Some of you guys are still. When you get something to work, never use these numbers again in the problem. You with me? Because now you got these better numbers. Yes. Don't always go back to the original numbers. If you get something to work, they don't exist anymore. You've already gotten something. When this went in, what factor is this related to? Excuse me. What factor is this related to? X.
Plus x plus 2.
X plus 2. And how many times did that happen? Twice. And then this was x minus 1. You guys with me? And then these 2 came from this leftover stuff. Whenever you get to the level where you have 0 remainder and then 3, that's x squared, x number, yes? And then you can either factor it or quadratic formula it, yes? You guys at all with me? So all I didn't do was I didn't kind of like put all the pieces together. I thought for sure I had to finish that one. Okay. And then both of these have the same issue, yes? They're missing stuff. So you had to put the zeros in there, yes? guys. I will see y'all tomorrow. I think tomorrow is supposed to be less rainy.
I really hope so.
Although San Diego, I used to live in Virginia Beach, so everything's inverted. Now I love when rain comes.
JB?
Huh? Virginia Beach. Yes. Norfolk. I used to live in Norfolk, Virginia.
That's where I went to high school.
Oh.
Yeah, yeah.
Virginia is a
In
different
Elizabeth
state.
City.
Elizabeth City, yeah. What's happening? Oh my god, dude.
Need a rain jacket.
Is
Dude.
it wet?
It's so cute.
Oh.
Sorry.
Okay,
What's
I'm
up?
a little
It's
lost
like
with this
freezing.
long
I'd be
division
better
one
off
because
wearing
you like
this.
did like the question marks in